Good morning, guys. Myself Sridhar H, working as assistant professor in the Department of Electronics and Communication Department at Government Engineering College, Haveri. Today, in this session, that is session 8 of module 4 in basic electronics, that is BJT applications, feedback amplifiers, and oscillators, we are just going with the Wein bridge oscillator. So Wein bridge oscillator. The Wein bridge oscillator is a type of phase shift oscillator which is based upon a Wein bridge network comprising of 4 arms connected in a bridge fashions. Okay, so here the 4 resistors are connected with the bridge factors, that is A to B, B to C, and C to D, with the resistor along with one is connected with the series and another capacitor is connected within parallel along with the resistor R, and R1 and RF are been free. 2 ohms are purely resistive while the other 2 ohms are combined of resistors and capacitors. So this one is the feedback circuit of, that is op-amp of a non-inverting amplifier. See, the output is fed back to the input at the A point, and the output is been of a D is being connected with the one positive terminal and B is connected with the negative terminal. The output is being fed back as the input, okay, to the bridge. Next, a portion of the output is fed back through the voltage divider network, that is a series combination of a resistor and a capacitor to the positive C. The output is being fed back to the what? To the resistor R and C connected in series and along with the feedback resistor, that is the REF. Next, the second portion of the amplifier is back to the inverting or the negative terminal of the amplifier through the impedance of magnitude 2R. The Wein bridge oscillator works as a sine wave generator whose frequency of oscillations is determined by the R and C components. Okay, the same, it is same as the RC phase shift calculator. So it is just the connections how it has been just changed, and the total oscillation frequency of the oscillation is totally determined by the R and C components. The gain of the operational amplifier is expressed, that is the formula is A is equal to 1 plus RF by Rn. See, RF by Rn, that is the thing. Next, the gain of the non-inverting amplifier must be minimum of 3 to satisfy Barkasian criteria. Okay. Next, therefore, that 1 plus RF by Rn is greater than or equal to 3, then RF by R1 is equal to what? Greater than or equal to 2. So that is 1 plus RF by Rn means 3 minus 1 is what? 2. Therefore, the ratio of the resistance RF must be equal to or greater than 2. So for Wein bridge criteria, for Wein bridge oscillator, the criteria should be what? It should be greater than 2, and the frequency of the oscillation is given by the formula what? The same thing, F is equal to 1 divided by 2 pi RC. Next, the resistors, how it will be just connected in a thing. The one arm has resistor and a capacitor connected in series R1 and C1, and the other hands has terms in parallel R2 and C2. Okay. 2 arms of the network behave identical to that high pass filter or the low pass filter. Okay. See, when it is being connected in series, then it is known as a high pass filter. When it is connected in parallel, then it is of a low pass filter for the input as well as the output. Okay, so this one is the circuit what will be. Instead of this, further we will be just using this kind of a circuit connection. Okay, next, in this circuit at high frequency, the resistance of the capacitor C is born and C2 will be much lesser, due to the which the voltage V0 will become 0 and R2 will be just shorted. And the next, at low frequency, the reactance of the capacitor C1 and C2 will become very high. So they are just change the figure of the previously what we have just for the Wein bridge oscillator. Now it has been changed to this one, that is the same combinations we have just rearranged in this fashion, that is R2 and C2 should be in parallel and R1 and C1 is been just in series, and the output of the amplifier is being connected with the what? To the R1 and series, and another output is being fed back with the R4, and it is being in series with the R3, that is of connected to a ground. Okay, so this one is just the same figure what it is been represented in the previously in the first slide. Okay, see here. So the same circuit it is being replaced in this fashion. Okay, just for the connection purpose. Next, the resonant frequency of the Wein bridge oscillator is calculated using the given formula, that is Fr is equal to 1 divided by 2 pi square root of R1 C1 and R2 C2. But if we just represent, if R1 and R2 is equal to R and C1 is equal to C, then the formula for FR is equal to 1 divided by 2 pi into RC, because 2 pi, so if you just compute, then it will be having R square into C square, that is RC whole square, then the square root will be just cancelled, then we will be having the formula that is FR is equal to 1 divided by 2 pi RC. Okay, see the same thing what the Wein bridge oscillator, so this one is just the connection purpose. Next, the basic Wein bridge are used to lead the lag network in the positive feedback loop to select a specified frequency that is amplified. The voltage divider is the negative feedback loop, sets the gain to make up the attenuation of the feedback network, and the Wein bridge oscillator circuit can be viewed as a non-inverting amplifier configuration without the input signal feedback from the output. See, the output is being fed back to the this one, and this one is the Wein bridge oscillator circuit, and this one is acting as a voltage divider circuit, and this one is acting as a lead lag circuit. Next, so what it is, if ACL is equal to 3, and if ACL is equal to 3, so then it will be what? Positive feedback loop with a phase shift of 0 degree, and this one will be having a loop gain of, that is 3 into 1 by 3 is equal to 1. So if you are just taking of ACL is equal to 3, then you will be having a what? The phase shift of 0 degree, and if you are having directly the 3, then it will be having the phase shift of, that is the loop gain is equal to 1. That is the closed loop gain of the non-inverting amplifier, that is 1 plus 2 R1 and R2 is equal to what? Since there is a loss of 1 by 3 of the signal in the positive feedback loop, the non-inverting amplifier must have a gain of exactly 3.0 set by the R1 and R2 to make the form of attenuation. So it has been explained in the just the previous slide. Okay, so how it has been just calculated is R1 plus R1 divided by R2 is equal to what? Less than or equal to 3. That is R1 is equal to, or if we just take then R1 by R2 is equal to 2, that is R1 is equal to 2 into R2. So this one is the thing. So this one is the formula, that is R1 is equal to 2 into R2. Okay, so Wein bridge oscillator. So if you just calculate what will be heading at a 1 by 3, that is phase shift of 0 degree, that is lead lag circuit, that is of 0 degree, and the voltage gain around the loop. See, this one is the thing. So when there is a ACL is equal to 3, then we will be having a damped oscillation output, and if we are having a loop gain of 1, then we will be having a constant sinusoidal wave. So this one is just the damped sinusoidal wave. Okay, just so you just go through one of the problem. So first, determine the RC values of the Wein bridge oscillator circuit for the operation of the frequency of 10 kilohertz if R is equal to 10 kilo ohms and R1 is equal to 1 kilo ohm. So we just want to calculate the what? The RC value. So given value is what? F is equal to 10 kilohertz, resistance R is equal to 10 kilo ohm, and R1 is equal to 1 kilo ohm. The formula for the frequency is what? 1 divided by 2 pi into RC. Okay. Next, so then C is equal to what? 1 divided by 2 pi into R value is there, C, so you should calculate F value is there, then what? C we just calculate is what? 1 divided by 2 pi into 100 into 103 into 10 into 103. Okay, actually it's 10 raised to 3 and 10 raised to 3. The final sustained oscillation gain must be of, that is, we will be getting of a capacitance of, after calculation we will be getting out of 1.59 nanofarad, and the sustained oscillation gain must be greater than 3, that is A greater than or equal to 3. Then the formula is what? Then 1 plus RF by R1 greater than or equal to 3. Then RF by R is equal to what? Is equal to 2. Then RF is greater than 1 kilo ohm. So R1 is equal to what? 1 kilo ohm. So R1 into 2 is what? Is equal to, we will be having of R1 divided by 2, that is of therefore RNC values are 0.1 nanofarad and 1 kilo ohm respectively. Okay. Next, so determine the maximum and minimum frequency of the oscillations of the Wein bridge oscillation circuit having a resistors of 10 kilo ohm and a variable capacitor of 1 nanofarad to 1000 nanofarad. That is, the frequency of the oscillation of a Wein bridge given by the formula is what? 1 divided by 2 pi RC. So this one is the frequency formula. And the Wein bridge oscillator low frequency is given what? That F minimum is equal to 1 divided by 2 pi into so 9 nanofarad is given and 1000 years. So you will be getting of less than is what? 1000 nanofarad. So just multiply that with 1000 nanofarad, then you will be getting the value of, that is minimum will be 15.9 hertz. What that is for the highest frequency, what you will be getting for the same formula, instead of capacitance value, instead of 1000 you will be getting for a 1 nanofarad, then you will be getting a value of 15915 hertz. Okay, for F minimum it will be 15.9 hertz, and for F max it will be what, 15,915 hertz. Okay, so this completes your Wein bridge oscillator. The only formula what you should be remembering is what, F is equal to 1 divided by 2 pi RC, and also the gain, that is 1 plus RF by R1 is equal to greater than or equal to 3. Okay, thank you.